All right, so today we're going to be talking about factoring polynomials, which is basically taking something that's kind of long and drawn out, like those multiplication problems we did today, and working them backwards. We're going to be working them into factors. So a few things to remember, you'll see what I mean when we get there. You should already know all of these things at the top. Solutions are the opposite of factors, so like if you have x plus 3, that gives you an answer of x equals negative 3. Degree equals the number of solutions. If you have x to the third, that means you should be expecting 3 answers. You should always factor out the GCF first. We're going to do an example like that. And then just remember your basic trinomial, bottoms up, and difference of squares factoring. Today we're going to add to that, and I'm going to move quickly. We're going to add to that sum and difference of cubes, which is a new pattern. It's similar to difference of squares, but there's a few differences there. And then, well, that's not a word, but it should say grouping as a factoring method, and we'll look at that example today too. So let's go ahead and get started. All right, so our first is an example just reminding you of GCF. And now this says to factor. I'm going to add another step just because I feel like you all can handle that right now, which is to go ahead and solve. So let me zoom in. So if we're solving, all we're doing is setting this equal to 0. So the first thing we want to do is take a GCF out of this. So if you think about 6, 15, and 6, you should notice that all of those divide by 3, and that you can also take an x out of all of those. So that's going to be my GCF is 3x. So the next thing I'll do is think about if I were to distribute 3x, what would give me 6x to the third? And hopefully you come up with 2x squared, right? So you're just undistributing. So if you take a minute to think about that, this should be plus 5x and plus 2. Okay, so notice that we've already kind of fixed this so that now I have a quadratic on the inside, which is something that I can solve, this trinomial. So I'm going to take this for a minute and do my normal factoring. This is an example of bottoms up. So that gives me 4 on the top, 5 on the bottom, and my two numbers for that are going to be 4 and 1. So when I set up my factors here, and I'm going to do this in red just so you see I'm kind of doing a separate step. This is x plus 4. Don't forget you're doing bottoms up. So over 2, x plus 1 over 2. All right, and we're going to simplify where we can. This is going to give me 2x. Whoa, that's a lie. 4 does divide by 2, so this is just x plus 2. 1/2 doesn't simplify, so I'm going to bring the bottom up, 2x plus 1. And then we want to bring that GCF term down from the front, which is the 3x. All right, so this currently is my factored form. If you want to make a note to yourself that this is the factored form. And then the only other thing we could do is to solve and find solutions. So this should get pretty easy. You're just setting each of these equal to 0. So 3x equals 0, x plus 2 equals 0, 2x plus 1 equals 0. All right, and when you do that, if you solve each of those, you get x is 0. That's one of my solutions. Negative 2 will be the next one. And if you work that out, you should get negative 1/2. So those are your 3 solutions to that polynomial. All right, the second thing we want to talk about is some of these new factoring patterns. So you already know difference of squares. You may not have seen it written that way, but you understand that we break like the perfect square apart into its 2 components and they create conjugates. So what's new today that we need to be taking a note of is sum and difference of cubes. And I'm going to do an example to kind of explain how that works. But that is these 2 right here, and I would write those down for yourself. Just write the pattern, sum and difference of cubes. All right, so our cube numbers they're perfect cube numbers. It's where you have like 2 times 2 times 2, what does that equal? So let me make a little list of those for you. All right, there's your little list at the top that I would add to your notes for reference. I'll have that on the board for you tomorrow too, just so we can keep practicing with those. So let's look at how we actually factor one of these problems. We're going to factor this using difference of cubes, and we're also going to solve it. So I'm going to just set it equal to 0 just for the sake of example. Okay, so if we're factoring, it says the first thing that we do, obviously you should take it out of GCF if you have one. 27 and 64 don't have anything in common. There's nothing you can divide those into, so that's just going to stay like it is. So the first parenthesis is really easy. There's like a short one and a long one. So the first one is just the straight like cube roots of each of those. So 27x to the third becomes 3x. 64, that's positive 64, becomes plus 4. All right, that's that first parenthesis. Like I said, it's a pretty simple one. All right, you're going to square the first number and square the last number, which is exactly what your pattern says up there at the top if you read it. Like it's telling you to take this number and square it. Take this last number and square it. So I'm going to do that. 3x squared gives me 9x squared. And then plus 4 squared is going to give me plus 16. And then the middle pattern, you're probably going to need to write some of this for yourself in words. This middle is a times b with an opposite sign. So I'm going to multiply these two numbers together, but change the sign. So if you multiply that, you get 12x. Well, in my problem, I'm going to write minus 12x. Okay? So that's my factor. Those are my factored forms. That's the final answer if it just says to factor. So I'll write that. This is factor. And then if we want to solve, we're going to set those equal to 0. So this is the nice thing. 3x plus 4 equals 0. You can solve that, and you should get x equals negative 4 over 3. This other is not going to solve. These are going to be imaginary roots. And for right now, we can say imaginary roots, and I'm going to write QF because you would use quadratic formula. Right now, we're not actually going to do that. We're just going to write imaginary roots, quadratic formula, and pretend like we don't know how to do that because you don't want to. All right, one more example. All right, this last example is factor by grouping, and you probably need to write down that factor by grouping happens when you have 4 terms, okay? Notice that in this problem, there's no GCF I can take out, and I can't do like difference of cubes or quadratic or anything else because I've got 4 terms going on. So what we're going to do is we're going to group them just like this. Okay, take a note that I just fixed a typo that I had, or a right-o. This should be a minus sign at the end there. All right, so we've grouped, and what we're going to do when we do grouping is we kind of do GCF like by group. So we're going to pretend like one of the groups doesn't exist for a minute. So GCF in this first one is going to be x squared. So if I write what that will be, that's going to give me x plus 1 if you factor that out. On the second one, there's not really anything you can take out other than a negative 1. So this is going to factor to be x plus 1 when you do that. And I'm going to make this, again, just because I can, equal to 0, equals 0. All right. So now when you do grouping, you should notice that these two groups match. So it's like that has now become the GCF, and what you're left with on the outside makes another factor. So let me show you what I mean. This becomes x plus 1 times x squared minus 1. So take a second to see where I'm getting that from. Now you always want to check if you have an x squared that what you have is finished, or if you can keep going. So notice this second factor has an x squared in it, and hopefully you recognize that is difference of squares. So that's actually going to keep going, that one factor. So this is going to become, I'm going to bring the x plus 1 down. Difference of squares is going to break apart to become x plus 1 and x minus 1, right? X squared breaks apart to give you x and x, negative 1 to give you plus 1 minus 1, equals 0. All right, this is a factored form. If you wanted to simplify it, you could write x plus 1 squared, since you have 2 of them, times x minus 1. All right, so here's your factor. And then the only other thing that we could do is to solve roots. So if we go ahead and solve roots for that, man, I'm struggling. If we go ahead and solve roots then, you should see here that x is going to give you negative 1. That's a double root. And x is going to give you positive 1 there. So those are indeed your 3 roots, which I knew I should have 3 because remember my original problem up there said x to the third, so it should give you 3.